Starting with lesson 8 practice problems. Number 1, the picture shows a circle divided into 8 equal wedges, which are rearranged. So the radius of the circle is r, and the circumference is 2 pi r. That's another way to say pi times diameter, because 2 r's, 2 radii, is equal to diameter. So how does the picture help to explain why the area of the circle is pi r squared? I notice sometimes just through telling this to my students that some kids totally get this, and some they never see it, but others do, and it makes perfect sense to them. So don't get too concerned if you just don't understand this. It is kind of a weird way to explain it, but the best way that I could kind of go about this is just to say that what it looks like here, depending on the number of pieces that you break the circle into, you're going to get a shape that resembles a rectangle. This resembles more something along the lines of a parallelogram. But I've seen videos or whatever where you can just break it up almost infinite number of times, and it looks like a rectangle, more or less. It's not perfect, but it's pretty close. And but what we have to kind of keep in mind here is all right, so this part, that part of the rectangle, imagine that's a right angle, imagine that's perpendicular to the base or whatever, like it's going straight up, but that's the radius, right? That's the radius of the circle. All right, this part of the circle right here, this part, 1, 2, 3, 4, right? That represents, I'm not sure what part those are, but that represents this, this, I'm kind of exaggerating the parts here, but it represents those 4 parts right there. It represents those 4 wedges. That's half the circumference, right? That's half the circumference right there. So now pi is, well, it says in the problem, right? Pi is 2 pi r. 2 pi r. That's circumference. It's another way to do it. But this right here only represents half the circumference. So I'm going to do 1/2 times 2 pi r. 1/2 times 2 pi r, and that's going to equal that section. And what happens here is these cross cancel right there. Those cross cancel. And what you're left with is just pi and r. So we're left with pi times radius. Okay? And then when you guys find the area of a rectangle, you do base times height or length times width, whatever way you want to think of it. So you're going to eventually do, we're going to do, let's say the length is pi times r, and then times the width, which is another r. Okay? So let's say this is length right here. That's the width. And hopefully this makes sense to you. I know it's somewhat abstract. Maybe that's not the best word for it, but length times width. And then you can kind of see where the r squared comes from, because right here you have r times r. And r times r means r squared. R squared. So if we were to break that down even further, that's going to be pi times radius squared, and that equals area of the circle. So that's where that comes from. Take away what you want from that, but I believe that's pretty good. It's the best I can do. So, all right, number 2, circle circumference is approximately 76 centimeters. All right, approximately, so it sounds like we're rounding here. Estimate the radius, diameter, and area of the circle. Estimate those things. So here's what I'm going to do. Here is what I am going to do. I know that, I'm just thinking right now to myself, but there's a lot of different representations for pi, and we could say that pi, one representation is 22/7. Okay, with an emphasis on that 7 right there. 22/7. So what kind of jumps out at me. I know this is hard for some people to see with estimation, but what I see there is that 76 is pretty darn close to 77. And the reason I like 77 is because that is a number that divides by 7, which is the denominator of pi, the ratio equivalent of pi, 22/7. So that's what I'm going to do. So I'm going to do oh, wait a second. I'm going to do 22, pardon me, I'm going to do 77 divided by pi, 22/7. Oh, wait, that doesn't go anywhere. Wait, darn it. Oh, wait, I could still do this. Could I? Nah, I can't do that. But whatever. I'm not thinking ahead far enough. Here's what else we could do. We're just estimating. I don't know if this is the best either. Maybe I can go down. Let's go down. Let's go down. This is kind of good for this kind of thing to happen because this is the thought process sometimes behind math. You got to just see what works, and if it doesn't work, try something else. Okay? This is estimation. This is pretty close to 75 centimeters. 75. And pi is 3.14, 15, all that kind of stuff. But if I really were to break it down, if I really were to truncate it, it's 3, right? It's about 3. Not exact. It's over 3, but it's about 3. So yeah, I should have done this first. So 75 divided by 3. That's basically circumference divided by pi, right there. Those are rounded numbers. Those are estimated numbers. And so I'm going to say that, that's going to be around 25. Okay? So that's right there. That's telling us the diameter. I'm saying the diameter is around 25. We know that 75 divided by 3 is exactly 25, but the diameter is around 25. So the diameter equals 25 centimeters. I should write approximately, by the way. And the radius will be half that. So half of 25 is 50. No, that's not. It's 12 and a half. 12 and a half centimeters. Okay? 12 and a half. And also we got to figure out the area. So we got to figure out the area. Now the area is pi times radius squared. So 5 times 12.5 squared. So I'm going to use my calculator for this. So 12.5 squared times 3.14. And that comes out to 490.625. So if we're just rounding this, we can say the area is around 491. I'm just rounding that up. And that's always square units, right? Square centimeters for that. Now your answers might be different, but they're probably close to mine. As long as they're close, you're probably okay. Estimation, you're allowed to be a little bit off. You're allowed to be close. Let's say your estimate was that the diameter was 26, or maybe the diameter was 25 and a half, or 24, or, as long as your numbers are close. Let's say you got a radius that was, 80 or something. That's way off. 80 is not close to 12 and a half at all. Or you got an area that's 1,000. That's over double the amount off there. So, yeah, you might want to recheck what you did. Okay. Moving on to number 3. It says Jada paints a circular table that has a diameter of 37 inches. What is the area of the table? All right, so this is not an estimation problem. So this is pretty simple. This is just pi times diameter. Not pi times diameter, sorry. I'm thinking circumference there. But this is pi times radius squared. So the table is 37 inches across. The diameter is that much, and then we want to do half of that, and half of 37 is Well, half of 36 is 18, right? So half of 37 is going to be, that's going to be what, 18 and a half? 18 and a half? So that's going to be 18.5, what is it, inches for that one? Yeah. All right. So why do we need that number? Because we need the radius, right? If you're finding the area of a circle, the radius is the number we need to square. So now we're going to do pi, here, because area is pi times radius squared. So we're going to do 3.14, all right, times 18.5 squared. That's what we're going to do. So 18.5 squared, and then times 3.14 equals, and I should do this more often, but I'm going to put approximately, because remember, whenever you're using pi, unless we're using the pi symbol, it's an approximation. It's not exact. We rounded it. So I'm going to put 1,074 and 665 thousandths. And this is square inches. Square inches right there. So that's the area of the table. All right, number 4, the carousel on the National Mall has 4 rings of horses. Kieran is riding on the inner ring, which has a radius of 9 feet. Mai is riding on the outer ring, which is 8 feet. All right, that's 8 feet further out from the center than the inner ring. So one rotation around the carousel, in one rotation of the carousel, how much farther does Mai travel than Kieran? All right, so and this is a hard problem because I've never been to this carousel, but what this problem is basically saying is, like, we've got these circles, and then we have these inner circles, something like that, and what's it say? Which has a radius of 9 feet. All right, so you can say, like, this circle right here, that circle has a radius of 9 feet. Okay, and then Mai's riding on the outer ring, which is 8 feet farther out. 8 feet farther out, so that's another 8 feet, which makes that 17, right? That makes 17 right there. So this right there is 17 feet. Okay, so that means, what does that mean? We're going to do, I'm trying to find the names here. So Kieran is in the 9, so let's do this. So it's asking basically how far they travel. So this is not an area question. This is circumference, because merry-go-rounds, carousels, they go in a circle. They go around and around. So you're going to do, for this one, we're going to do circumference. Just kind of recall what that is. That's pi times diameter. Pi times d. Okay, so we're going to do, for this one, 3.14 times, and I'm going to do this circle first. Do the inner circle first, which is that's got a radius of 9, so the diameter is 18. Pardon me. So that's 18 right there. And I'll do that. So it looks like Kieran went 56.52 feet. Okay. So that's one rotation of the carousel. It went once around. All right. So again, again, that is Kieran. I'm going to make sure you know what that number refers to. And those are Kieran's figures. All right, and then for Mai is she's 18 feet from the center, which gives her a radius of 18, but a diameter of 36. So for that one, we're going to do pi times diameter, and this time we're going to do 3.14 times 36. Times 36 right there. So you're going to do 3.14 times 36. And that is 113.04 feet. Okay, and so that's, so how much, oh, the question says how much farther does Mai travel than Kieran? How much farther? Well, we just have to subtract those. So we just have to do 113 and 400ths minus 56 and 5200ths. Just like that. Okay, and then 4 minus 2 is 2. 0 minus 5 is 5, right? No, it's not really. I mean, you're going to put a 5 there, but that's not the reason why. We're going to borrow from that, make that 10, and that's a 5. But remember, that had to become a 2. So you can't do 2 minus 6, so we're going to have to borrow from the 10s. So that becomes a 0, make that 12. So you got 6. And then, no, right here, I know it's you got a 0, but I see 10 minus 5, which is 56. Holy cow, that's exactly the same number. That's kind of weird. Kieran is, I knew that was going to happen, but Kieran is, their difference is exactly the distance that Kieran goes. So you could say that Mai is twice as far. You know, Mai is twice as far, but that, if you think about it though, Mai is not twice as far as Kieran. Kieran's 9 feet, you know, and Mai is 17 feet, which is kind of weird. All right, so one rotation of the carousel takes 12 seconds. How much faster does Mai travel than Kieran? So one rotation takes 12 seconds. So how much faster does Mai travel than Kieran? Well, we're looking for this one. We're going to need to figure out feet per second. Feet per second, you know, and that's exactly how the division is going to be done. Feet divided by seconds. Feet divided by seconds. So when we do Kieran, Kieran's going to go 56.52 feet in 12 seconds. And we're going to do that, 56.52 divided by 12. And that comes out to 4.71 feet per second. Alrighty, and then for Mai travels what, 56, oh no, sorry, 113.04 feet in same amount of time, 12 seconds. So 12 seconds. So we're looking for Mai's there. So we're going to do 113.04, divide that by 12, and you're going to get 9.42. So you can see Mai is on the outermost part of there. I didn't label that, sorry. Yeah, so Kieran, who's on the innermost part of the carousel, is going faster. Mai is on the outermost part of, or at least in the outer ring, further away from Kieran, and Mai's going at a slower rate, which makes sense, because when you think about, what first comes to mind for me is ice skaters. Ice skaters, when they're twirling around, and when they're spinning around, they bring in their arms. They bring in their arms really close, and that makes them go so much faster. So when they bring them close in, they're bringing their center of gravity in, lessening the radius, so that makes them go faster. Okay, so bringing it to the center, that works. I'm not sure if the physics of that works, but seems perfectly fine to me. All right, now let's see here. Number 5. Here are diameters for 4 coins. So we got penny, nickel, dime, and quarter. A coin rolls a distance of 33 centimeters in 5 rotations. Which coin is it? Well, let's just let's just do 33 divided by 5, right? Let's just do that. So 33 divided by 5, which should be what, like 6 something? $6.6. All right, that's 6.6 centimeters. All right. All right, so that tells you the circumference, right? That's the circumference. So the circumference is circumference equals pi times diameter. So I'm going to do pi times diameter equals 6.6. Okay, so what number, times 3.14 equals 6.6? So let's divide. Let's divide this. So we're going to divide both sides by pi. 3.14. Sorry about my handwriting there. So 3.14. So we're going to do 6.6 divided by 3.14. And that equals t equals 2.101, some bunch of numbers there. And that closely resembles the nickel 2.1. I would assume they rounded it or something. So that's the nickel. The most boring coin, in my opinion, of the American money. All right, a quarter makes 8 rotations. How far did it roll? All right, so we need to figure out the circumference of a quarter. So the circumference of a quarter is going to be pi, right? Pi times diameter, which is going to be 3.14, times the diameter of a quarter, which is 2.4. And then it makes 8 rotations, so multiply that by 8. All right, so a lot of multiplication here. So 3.14 pi times 2.4, right, the diameter of the quarter, times 8 rotations. So it's going to do 5 there, but 8. And so that I get 60.288, okay, centimeters. That's what I got. All right. All right, C, a dime rolls 41.8 centimeters. How many rotations did it make? Well, this is basically just like A. All right, so let's figure out the circumference. Okay, so dime rolls 41.8 centimeters. How many rotations did it make? Oh wait, no, this is not the same as A. I thought it was for a second, but it's not. So let's look at a dime. We need to figure out the circumference of a dime. So a dime is 1.8 across. So let's figure out the circumference. So that's going to be 3.14 times, this is a dime, right? 1.8. So 3.14 times 1.8. and that comes out to 5.652 centimeters. So that's the distance around a dime. Okay? One time around the dime is a little over 5.5 centimeters. All right, now this one did 41.8, so we're just going to divide. So we're going to do 41.8 divided by 5.652. And I get a really long number, but I got 7.3956, etc. So it made approximately 7.4 rotations. I'm rounding it. Or just 7 rotations if you want to round it to the nearest whole.